What'd you guys get?
I got for the capital R, I got .355.
Yep, that's what I got. Well, I rounded it up to 0.36 and 36%, but yeah.
I got. Then,
Oh, that was weird.
what?
We good?
Yeah. Okay. Then for the little r, I got like 0.64, like around there.
Yep.
Yep.
Sweet, 0.64. All right. B. I use Google calculators, so I don't know why. Sometimes so I look on the answer key, and it's always like a 0.1 or 0.2 off for some reason. So if it's off my calculator, I'm sorry. But for B, big R, I got 0.124 or 0.126.
Okay.
I
I
got
had 0.13.
What did you get?
I had 0.13. I rounded everything, and then I decided later not to, so.
I got 0.126.
Okay,
Okay.
yeah.
Yeah.
That's the answer key one. So 0.126. Big R, little r, I got 0.456, or answer key is 0.458.
I got that one.
Okay.
Okay. Yep.
And then little r, I rounded that one to 0.42 or 0.416.
That's what I got.
Okay. Yep.
Then C, I got 436 individuals.
I did that as well.
Mine was 438,
well.
but
Yeah.
close. So.
Then, let's see, D, I got 0.58 for the expected white phenotype. And the red, I rounded 0.42 or 0.416 also.
Okay, I got this as well, except I got 0.584.
Yeah, that's the
answer key.
Yeah.
Okay, so for number 2, I got for A 0.02.
Yep.
Yep.
And then 0.98.
Yep.
And then 0.0392. I might have had more like things.
Yeah, I rounded that one up to 0.04.
And let's see. And then I got 39 for the population.
Yeah, 39.
Yeah. Perfect. Okay. Oh, look, it's Richard.
Hi.
Hi. Finally made it. It was computer difficulties.
Yeah. We did the first 2 questions already, so we have 3 left.
Okay. I will ask about those later then.
Yeah.
Let's see.
Okay. What'd you guys get for 3A?
I got 0.99998.
Yeah.
I got the same thing.
On A, I got 99.37%.
Yeah, it's 0.999 or 99.9 whatever percent. So as long as that's more percent, it'll still be good.
Yeah.
I think so.
And then did you guys get 0.00002?
Yeah, for B.
0.63% on B.
0.3.
0.63% on B.
Oh.
I'm not getting the percentage at all. I'm like, wouldn't it be like 0.002%?
Yeah,
So
that's what I have.
Yeah, I just pulled up the answer key right here. Shows P equals 1 minus Q equals 1 minus 0.9998 equals 2.
I don't have the same first answer.
Yeah, that's probably what's throwing you off on all the rest of them.
Yeah, this is where I started making sure I wasn't rounding things. So, because that threw me off. My answers were different.
See, my P, just for P itself, I got 0.0063, and Q, I got 0.9936. So I see why I didn't square them.
Oh yeah, that's what happened to me the first time.
Oh, yep. Same.
Oh, yeah, I forgot about that, but when I do it, I remember it. It's really weird. I'm like, what did I do to get that answer?
Yeah, I didn't square my answers, which is why I didn't get the right answer.
Okay, that makes sense.
Okay.
Well,
And then what did you guys get for C?
1.25%.
1.25. Janessa, Jonathan, what did you guys get for that one? 3C?
0.39992 or something like that.
Yeah, point 0.00, all those zeros, 39999, whatever.
Huh. I must have done something different or odd.
What did you get?
I got 0.00008.
On C, it should be 2PQ. 2 times P times Q.
Yeah, so I'm just going to do that real fast. That's kind of confusing me. Hold on. Clear. 8 times 0.00002 times 2. Oh, I got something different. I got a 0.00004.
Yeah,
Yeah, it rounds up.
Yeah.
It rounds up. Okay.
Yeah.
Okay. So I got that one wrong. Anyways, fun. And then, so that means my D's wrong, too.
Yeah, I got 400.
Yeah, I got 400 too.
Okay. Let's move on to 4.
I've got much different numbers in all of you.
Okay, so what'd you guys get for 4A?
Let's see. 4A.
There's 4 different genotype frequencies. I got 0.0784. On the first one.
Yep.
Okay, I somehow got something different for the AB and then for the heterozygous B.
But I have the same thing. same problem. I got 0.0476 on the AB and 0.0935 on the BI.
See, I
I got something different than that.
yeah.
Let's see. So the AB I got 0.0952
Yeah.
because that one let's see, what did I do?
You
Because this is like this.
Yeah, you multiply
Yeah.
your A value and your B value times 2. So it's going to be
Yeah.
0.28 times 0.17 times 2.
That's right. Because the
You know
little
what? I think I know what I did. Maybe. Oh, you know what? I know what I did wrong for the B. For the B heterozygous, I times the 0.303 to B.
Oh,
I didn't
okay, yeah.
take that allele amount.
Oh, okay, I see that.
Because as I do it, like how they wrote it in there.
Yeah. Yeah, because the AA, that one's going to be the squared one, because that's like P squared. And the little I, that's like the Q squared. And then the other ones, because they're different, it's like the 2PQ
Mm-hmm.
or whatever letters they use to represent stuff. But yeah.
Whatever. Yeah, I think that's my problem. I didn't use the allele. I used the combined
Yeah.
answer. That makes sense. Okay. So some minor. My B is gonna be wrong for me.
Oh, yeah.
I still see question 3 on Jonathan's picture. I want to see 4.
What was that?
Can you scroll down
Your
to
share screen
Yeah.
is on 3.
go back on 4.
This is
Thank you.
Yeah.
All right. You know what happened is that I have to double my genotype frequencies for the heterozygous, and I would have the answers.
Oh, you didn't double it?
No.
Okay, that makes sense.
That makes sense.
I took the probability of getting 1.
So what did you guys get for B?
1870.
Yeah, 1870 individuals.
Awesome.
I have half of that, again, for didn't multiply it by 2.
Yeah.
Oh, yeah. That makes sense.
Okay, and then what'd you guys get for C?
So, the A blood type, I got 0.3864. Yeah. And then, what?
That they had. I had 23.24%.
23. Let's see.
You had 23.2. I mean, what am I saying? 0.232. I got that too.
Huh.
I got
But
I got the
we're wrong.
point.
Well, that's just p squared in of itself. It says this on this one that we have to add plus 2pr.
Yeah,
So-
because
Mhm.
A blood type,
Oh, I know what I did.
'cause
I
this
did
is-
the I did the 0.078 and times it by 2, or like powered it by 2, and then did that 0.078 for the next one.
Oh, okay.
I didn't bring it back down to its allele form.
Okay. Yeah, because this
Silly
is,
mistakes, and that's probably why I got AB wrong too.
oh, that would make sense. Yeah, because with the phenotype, there's
4.76.
there's 2 different genotypes that give you that A blood phenotype. Because the heterozygous AA and the A with the little I, those are both going to be A, so you have to put them both together. I honestly can't remember what I did. I just remember you have to put them together. Let me see.
And then I got the 3,030 for the last little bit. For D.
Yeah, that's what I
Oh,
got.
for D. Yeah, I got 3,025, but yeah.
I got 3,025.
Yeah, I didn't round up to 330, but yeah, that's what I got too.
Okay, and then 5.
I was a little confused on this.
I was so lost at first, and then I'm just kind of like, okay, I'm just gonna go for it.
Yeah.
So what did you guys get for the allele frequencies?
Frequency M, I got 0.915.
Okay.
Frequency N was 0.085.
Yep.
Yeah. 91.5% and 8.5%.
Mhm.
The chi-squared value, I got 373.4.
Mine was 0.2546.
I did only here I rounded up, but I'm like laughing at myself for that. So I got 0.36 for my chi.
Oh, okay.
I
I couldn't figure that out, so I didn't do it. I ended up doing the actual equation, the Hardy-Weinberg equation, and I got
That's-
1 out of all of it. So
Oh,
when I
okay.
did that, I had 30 minus 100 squared over 100 plus 168 minus 50 squared over 50 plus 2 minus 50 over squared over 50, and that's how I got 373.4.
Okay, so with this one, you had to do, so you had to figure out the expected. Let's see. I had, so I use like a little chart. I don't know if I hold this up if you can see it. I can't tell what it's looking at. Okay, that box.
Okay.
Mhm.
And that's how I figure out how many of each allele so I can like organize it. But then, so you have, altogether you have 366 of the M allele out of 400,
Yes.
right? And then the N was 34 out of 400. And then for MM, you would calculate what the P, did we do a P value?
I'm gonna guess that the p-value was 0.05 because that's usually what it is.
I on the MN, my expected I had should have been 100. Say 100.
Because my expected was 31.11. And let's see. Because,
Well, there's a total of 200 individuals in this um, group, and following normal Mendelian genetics, there should be 1/4 big M, 2/4 big N, big N, big M, and 1/4 big N, and that's how I used that to find my chi-square.
That's what I did in the first place. Then it looked wrong because I knew it was supposed to be semi close to 1 or like a smaller number. So then I kind of went away from that.
See, then that proves that it wasn't Hardy-Weinberg, because we have a little bit of change within the population, and there can't be any change within a population to be a Hardy-Weinberg equation.
well,
Correct?
the answer on the answer key is that you failed to reject the null
I'll fail
hypothesis.
to reject.
Yeah.
Whoops. Well, I put that down because I was just like, yeah, it's not that big of a margin to actually cause a difference.
Yeah, because I'm pretty sure my answers were the same as the answer key. Let's see. I just want to figure out how to explain it. So I put down that the big M was my P squared. The big N was 2PQ, and the N was Q squared. So then I figured out what my P squared was and multiplied that by the population total. So that's where I got 167.4 was what the expected MM was going to be. And then the expected MN is 31.1. And the expected NN was 1.4. And I think it's, I can't remember how I found my P. The P's and the Q's. I can't remember what I did.
Well, I'm already seeing already that I'm gonna have to redo this whole paper.
But she has a screencast showing you how to do this problem.
Oh, really?
This one.
Dang it! I didn't
Yeah.
remember.
Yeah, it's in the notes at the beginning of lesson 5 or whatever. She's got a screencast you can watch that explains it all.
I didn't know it was for this problem. I watched a couple of them, but must have missed this one.
I
Yeah,
also
she
I
just
also
she
did
just
this
put the link in like her description right there or
Mm.
whatever, one of the videos. It was just in her thing and it was for number 5, yeah. Under
I also did
Whoops.
assignment last week with doing it the wrong time, so that's probably.
Oh, that's right.
Yep.
But yeah, under just like the instructor notes or whatever that first thing is for this lesson, she's got a screencast thing that walks you through this problem too.
Okay, I'll have to take a look at that then.
But
Yeah.
like once she starts, like I only watched the first couple minutes and then I was like, oh, this makes sense. It's like it'll click once you see, you're like, oh, duh, that's what I should have done.
Dull.
Then you just do the chi-square thing, which we already know how to do, and then yeah. So
Okay, that's good to know. I'll have to check that out again.
yeah, it was helpful.
Again.
So. But yeah.
Well, I need the answers on what you all got on number 1 and number 2 because
Mhm.
they started without me.
Yep.
All right, here's my.
The-
You can just look on his screen.
Yeah, I'm looking at it. I'm see frequency of big R is. Yeah, I got the answer on A. Got the answers on B. C. I got that answer, and I got the same answers on D, on number 1.
Perfect.
You're good with number 1? Awesome.
Oh my gosh.
Sass master.
I got the 0.02% on A, got the 98% on B, and I got the 3.92% on C, and I got approximately 39 individuals. Got the right answers on that one.
Perfect.
Okay, we're good.
All right. Any
Awesome.
questions? That helps my problem 5 thing that you shared, Tanisha. So that's all the questions.
Yep.
Okay.
I think
I'm
we're
good.
good. I'll
All right.
post this up